All right. So let us begin our class today. Chapter 12. Okay, chapter 12 is being divided into two main subtopics. The first one is the heat conductions, and then the second subtopic is the thermal expansions. So we're going to look at the heat conduction first. So heat conduction, it tells you, okay, how an energy is flowing from a hot end to a cold end. So remember, energy is not the same as the temperature. They are two different things. When we talk about heat, it's about energy. Okay, you're talking about energy. You're not talking about whether an object is cold or is hot. If you want to determine the degree of hotness of an object, then you look at the temperature. So in which it means heat is not the same as temperature. They are two different things. Heat is a form of energy, and temperature, it tells you the degree of hotness of an object. Okay, so first of all, if you look at these equations, we have dq over dt equals to negative ka dt over dx. So it tells you the rate of heat flow. Okay, how fast a heat can flow from a hot end towards a cold end. So dq over dt. So whenever you're talking about the rate, you need to divide it by the time. Okay, that's why you have a dt right here. So these equations actually contains quite a lot of information. The first thing, well, of course, the rate of heat transfer, because that is the name of these equations. And then we have a things called K, a variable known as K, which we call thermal conductivity. Okay, thermal conductivity. Now, what is thermal conductivity? What is the functions of thermal conductivity? Thermal conductivity, it tells you whether an object is a good conductor or not. Okay, an object with greater thermal conductivity means it is a better conductor compared to an object with a lower thermal conductivity. And then A is the cross-sectional area of the object. Now again, what does it mean by cross-sectional area? It is the surface area that is perpendicular to the surface that has a direct contact with the heat. So for example, now this is my object. Okay, this is a road. So the road, this surface area is a surface that is in contact with the with the heat, the source of the heat. Okay, so you heat it up from this end. So this surface is in direct contact with the source of the heat. Therefore, this is the surface area that we're going to use in our calculations. So remember, A is the cross-sectional area of the surface that has a direct contact with a source of heat. It is not the total surface area. All right, that is a very common sin mistake in exam where students tend to calculate the total surface area of the object, which is wrong. Okay, cross-sectional area, it just refers to this area. And then dt over dx is the temperature gradient. Okay, temperature gradient, it shows you how heat is flowing from a hot end towards a cold end. And then, of course, you need to plot a graph of t against x in this subtopic. All right, so a t against x graph is the graph that we're going to plot. All right, so this one we'll go through it again when we go through the exercise. So I'm going to skip it for now. So this is the equations. Now, sometimes questions will give you two joint road. Okay, two road that are being joined together. For example, like this one. Okay, so now you have a road A. And then there's another road that is being connected to it. Okay, so this would be a road B. So road A and road B, they are being joined together, and then you put an insulator around them. Okay, you put an insulator, you wrap it with an insulator. So this is insulator. Now, what does it mean by insulator? Insulator is prevent heat from flowing out from your conductor. Okay, it prevent heat loss. So now if you have a joint rod, if you have two joint rod and then you wrap it with an insulator, if the question tells you, now this joint rod is in steady state, okay, you have something called steady state or in a steady condition, then it means the rate of heat transfer in rod A, which is your dq over dt in rod A, is now equals to dq over dt
Rod B.
in rod B. Okay, so they are the same. So now this is what happens at steady state. Now, sometimes if you go through the questions, if you go through the exercise 1, some of the questions, they didn't mention steady state. But in your syllabus, we assume they're in a steady state. So even though the questions didn't mention it, but if you are given a joint rod case with an insulator being wrapped around them, then we assume it is in steady state. Okay, nanti kalau kamu tengok soalan, memang ada soalan dia tak sebut perkataan steady state. Tapi di dalam silibus Anda, kalau dia tak sebut pun, kita anggaplah dia steady state. Sekiranya dia ada wrap dengan insulator dan sebagainya. So now what does it mean by a steady state then? What is the purpose of this equation? What does it mean by this equation? It tells you the rate of heat flow inside rod A is now equals to the rate of heat flow inside rod B. Now, it doesn't mean that both of them, they have same temperature. Okay, for example, if you look at this diagram, the diagrams that I gave you here, so rod A now, let's say this is a source of the heat. It begins with 100 degrees C. Okay, so rod B, well, it could be 60 degrees C. And a joint N, it could be 70. Okay, for example, 70. So now, this N, okay, at these three positions, they all have a different temperature. But when it comes to the rate of heat flow, they are flowing at the same rate. Okay, the energy is flowing at the same speed from rod A, from this initial point until the ending. Okay, until the final positions. So this is the meanings of the rate of heat transfer. You are looking at how fast the energy is being transferred. So it has nothing to do with the temperature at both ends. All right, so they could have a different temperature. It doesn't mean that they must have same temperature at both ends. Okay, so that is a heat conduction. All right, and now one last thing. Let us go back to the original equations. dq over dt equals to negative k dt over dx. So what is the meanings of this negative sign? Now this negative sign, it tells you the heat always flow from high temperature towards cold temperature. Right. In other words, if you expand these equations, dt, now dt carries the meaning T final minus T initial. So T final minus T initial, where is your final positions? Where is your initial positions? If you look at the diagram here, okay, you look at this diagram. Okay, you look at this diagram. So if you are talking about the initial position, it is a place that is in contact with the source of heat. Okay, which means it's the hot end. So this is your initial position and this would be your final position. So based on the diagrams given, okay, we can tell that initial positions has a higher temperature and final position has a lower temperature, which means your T initial is always larger than your T final. So if you use Tf minus T initial, then you're going to obtain a negative value, and this negative value will cancel out the negative sign in your equations. And eventually you will obtain a positive rate of heat transfer. So dq over dt is always a positive value. All right, it is always a positive value. So if you remember the things that I told you in lecture, sometimes if you look at reference book, okay, if you look at the reference book, ada buku rujukan. Okay, kalau kamu tengok buku rujukan, some reference book they tells you dq over dt is equals to just ka. Okay, ka dt over dx. This is the equations that is being given in most of the reference book. All right, and this is actually not correct. Why? Because they are assuming your dt is your large t minus a small t, okay, the smaller t, the larger t minus a smaller t. So that is according to reference book. So I don't want you to use these equations. I want you to stick to the original equations with a negative sign. Okay, so use the equations with a negative sign because that is the right equation. So the one that is given in your reference book, okay, is a shortcut equations where they assume dt is your larger t minus a smaller t, which means it's a hot end minus cold end, which is wrong because hot end is indeed the initial position and cold end is the final position. All right, so don't use the equations in your reference book. So buku rujukan dia memang bagi kamu shortcut sebab dia anggap kamu guna T besar tolak T kecil. Okay, jadi dia tak ada negative sign dalam buku anda. So sentiasa pelajar keliru. Dia tanya saya yang mana satu betul. The one with negative sign is the right equations, is the correct equations. Okay, now let's look at questions 1. A major source of heat loss from a house is through windows. Calculate the rate of heat flow through a glass window. Okay, that is 2 meter times 1.5. Now, this one we call dimension. Okay, so dimension 2 by 1.5 meter in area and 3.2 mm thick. If the temperatures at the inner and outer surface are 15 degrees C and 14 degrees C respectively, so now calculate the rate of heat transfer. Okay, so question asking for dq over dt So dq over dt is equals to negative ka dt over dx. That is what we know based on the definition. And it can be written as negative ka t final minus t initial divided by dx. So now let's see, do we have enough information to solve these questions? All right. So first of all, this is a glass. Okay, so because this is just an exercise and it expects you to find the values of K in your notes. So let us go back to the lecture notes. So lecture notes tell us the glass K is equals to 0.8. Okay, given K is equals to 0.8, that is for glass. So this is the value that we're going to use in questions 1. In exam, don't have to worry about this value. Okay, you don't have to memorize it. It will be given. Just that in this exercise, in your exercise 1, okay, they expect you to find the K from your notes. Okay, so dalam exam tak payah hafal. Okay, dalam exam tak payah hafal. Dalam exercise, dia nak kamu cari sebab sudah diberi dalam nota anda. So given K is equals to 0.8, W M negative 1, K negative 1, and then the cross-sectional area now, the area given, well, if you look at the value, if you look at the diagram, you have 2 meter by 1.5 meter with a thickness of 3.2 mm. Which one should be used as the cross-sectional area? So you look at the diagram, okay, you look at the diagram. The surface area that has a direct contact with the source of heat, okay, with the heat, is the large surface area here. Okay, it's not the thickness, it is this large surface area. So this is what we call cross-sectional area. Okay, dia ada impact yang direct dari heat. Heat dia kena terus pada surface area ini, dia bukan kena pada thickness. So we call this one cross-sectional area. So cross-sectional area given is a 2 times 1.5. So A is equals to 2 times 1.5, which is equals to a 3 meter square. So that is our A. And now which one is T final, which one is T initial? If you remember the things that I told you just now, heat is always flowing from high temperature towards lower temperature, which means 15 degrees C is your initial temperature and 14 degrees C is your final temperature. All right? And then the dx is the distance traveled by the heat, which is the thickness. Okay, so the thickness is 3.2 mm. So we have a x equals to 3.2 mm. Remember to change it into SI unit. So it is equals to 3.2 times 10 to the power of negative 3 meter. Now that you have all of the informations, okay, you can then plug it into the equations. Therefore, I'm going to find somewhere else to write it down. Okay, therefore, dq over dt is equals to negative 0.8 times 3 times, now t final, if you remember, is a 14. So 14 minus 15 will give you a negative value. Negative and the negative right here, they will cancel with each other. So divided by 3.2 times 10 to the power of negative 3. So eventually you will obtain a positive value that is equals to 750 joule per second. Okay, so for every second, this amount of heat will travel from the hot end to cold end. All right. So for 1 second, the energy flow in 1 second. So 750 joule per second. So that is how you solve questions 1. So now I give you 2 minutes to write down the summary and also the solution for questions 1. If you have any questions, you may ask. Okay, so 2 minit untuk Anda catat summary serta jawapan untuk soalan 1. Kalau ada sebarang pertanyaan, Anda boleh tanya.
Perasaan hidup kami kan tumpang pada apa?
All right. Okay, now let's look at questions number 2. So questions number 2. Oops. All right. One properly insulated copper rod of length 20 cm and cross-sectional area 2 cm square is maintained at a constant temperature, while the other end is at temperature 0 degrees C. If the rod is in steady state, so now you have a rod. Okay, this is a copper rod, and then this end is 100 degrees C and the other end is 0 degrees C. And the length of the rod is 20 cm. So you have x equals to 20 cm. Remember to change it into SI unit, which is equals to 0.2 meter. And given cross-sectional area, so this is your cross-sectional area, A is equals to 2 cm squared. Now, cm squared is not SI unit. You need to change it into SI unit. But it is not times 10 to the power of negative 2. It should be negative 4. Okay, 2 times 10 to the power of negative 4 meter squared. So if you forgot how to do the unit conversions, okay, you should do some revisions right now from chapter 1. Okay, so do revisions chapter 1, then you should know how to do the unit conversions. Okay, now questions A. Questions A asks you to calculate the temperature gradient. So temperature gradient equation is dt over dx. So dt over dx can be written as T final minus T initial divided by dx. T final, again, T final is the cold end, which is here, and T initial is the hot end, which is here. So therefore, temperature gradient is then equals to 0 minus 100 divided by, now the length is 0.2 meter, so it is equals to negative 500 degrees C m negative 1. Okay, now when it comes to the change in temperature, it doesn't matter whether the unit is in Kelvin or is in degrees C. Okay, so even though Kelvin is the SI unit, but when it comes to the change in temperature, when you're looking at delta T, value in K is equals to the value in C. Okay, value in K is equals to the value in C. That is what happens when it comes to delta T. But if you're just looking at the temperature, then they are not equal. Okay, 1 degree is not equals to 1 Kelvin. But if you're looking at the change in temperature, then yes, 1 Kelvin is equals to 1 degree C. Okay, kalau change nilai dalam Kelvin sama dengan nilai dalam degree C. Tapi kalau Anda cuma tengok temperature dia tak sama. Okay, 1 degree C is equals to 2, 3, saya dah lupa dah nilai dia. Okay, we'll look at it in the next chapter, don't worry. Okay, just remember, even though Kelvin is SI unit, but when you're looking at change in temperature, it doesn't matter whether the unit is in Kelvin or in degree C, because they are the same. Okay, now let's look at questions B. The temperature at the 0.4 cm from the hot end rod. So now, okay, now what the questions want? The questions doesn't want the temperature as a 0 degree anymore. It wants to see what happened at 4 cm from hot end. So let's say this is here. Okay, so this is 4 cm from hot end. So what is the temperature at this position? That is what the questions want. Okay, that is what being asked in the questions. So now how are we going to calculate it? If our object is in steady state, then it doesn't matter which part of the object that you are looking at. All of them, they are going to have same dt over dx, provided you're looking at the same rod, okay, same material, same rod, and then you didn't change any of the factors. Okay, you didn't change the insulator, you still have the insulator in it. You didn't change the size, nothing. Then it will have the same dt over dx. So for questions B, the temperature gradient is still equals to negative 500 degrees Cm negative 1, because you're looking at the same rod. Okay, you're heating it up with the same source of heat. You're not changing anything. Okay, you're not changing anything. So therefore, the temperature gradient is still the same. Then how about cross-sectional area? Well, it's still the same because you're still looking at the same road. So A is still equals to 2 times 10 to the power of negative 4 meters squared. All right, and then what else is missing? The K is missing. So do I have the K now? Oh, yes. Okay, questions that give me the K. So K is equals to 3x0W m negative 1 K negative 1. Okay, m negative 1 K negative 1. Yeah. So now let's see, how am I going to calculate? So what is the equations that I should use to solve this question? Do I need A and K? Well, actually not yet. Okay, I don't need it yet. I can solve it by just using the temperature gradient equations, which is dt over dx equals to T final minus T
T
initial.
initial per
Yeah.
dx.
Okay. So T final minus T initial over dx. So the value that I should use right here, okay, now dt over dx still negative 500. But now my final temperature is x, is unknown. Okay, so instead of x, I'm going to write it as TF
Tf.
because I have x already. Okay, saya sudah ada x
Oh,
di sini, jadi unknown saya tak nak guna x lagi. Kalau kamu guna x lagi, nanti dia jadi keliru. So kekal dalam TF. Okay, you keep it as TF. So minus initial
that's
temperature.
100. 100
Good.
Celsius.
100 and then divided by
0.04.
good 0.04. Okay, not 0.2 anymore, but it should be 0.04 because question asks you to determine the temperature at the point 4 cm from hot end. So rearrange the equations. T final is then equals to 80 degrees C. So that is your questions B. Okay, that is your questions B. Then a question C. Okay, now question C. So question C, the rate of heat flow. Now the rate of heat flow is up to you whether you want to use the information from questions B or questions A. Okay, both of them, they should give you the same answer. So now let's look at the question C. Okay, the question C, I have a rate of heat flow dq over dt. dq over dt is equals to negative Ka dt over dx. Right? So a negative K, okay, so equals to negative, my K is 3x0. A is 2 times 10 to the power of negative 4. So dt over dx, we have only one value, which is,
Negative 500.
okay, good, negative 500. So just plug it into your calculator. Eventually, you will obtain 38 joule per second. So that is how you solve it. Okay, that is how you solve it. So the key point in this question is to tell you the temperature gradients along the road, they are the same. If you are looking at the same road, okay, if you are not changing anything in the questions. Alright, so kalau kamu ada road yang sama, dia punya temperature gradient akan sama. Tak kisah, it doesn't matter whether you're playing at the positions of 1 cm ke, 2 cm, 3 cm, 4 cm, anywhere along the road, they will have same dt over dx. Alright, so now I give you 2 minutes to write it down. Okay, so maybe you can write a short notes here to tells you what happens in questions A and questions B. Okay, how can I use a negative 500 in both questions? What is the reasons? Okay, you just make a short note. Tulis dalam ayat dan anda boleh faham. So 2 minutes for you to write down the solutions as well as short notes. Okay, kamu sendiri catat short notes before we proceed to next question.
Madam,
Ya.
saya beri tanda jap.
Okey, boleh. Okey, kita tunggu rakan anda sekejap, mungkin dalam 2 minit. So kalau anda nak pergi tandas, bolehlah pergi. Kalau anda ada maklum, saya boleh tunggu anda, tak ada masalah. Okay, so a short break, 2 minutes. Okay. So let us continue. Now, questions 3. Questions 3 now, you look at the diagram, you know
madam.
this is bagus. So now let's look at questions 3. Questions 3, now you have 2 joint roads. Okay, so 2 properly insulated uniform roads D and E make thermal contact at one end as shown in figure D and E. Okay, shown in figure below. So you have D and E here. So I'm going to put a color here to make it easier for me to see. So D, I'm going to put it a blue color. And then E, I'm going to put it as a green color. Okay, so I have road D and road E right here. So usually when it comes to these questions, I like to label the diagram first, okay? Because now you look at the diagram, you have a value, but without a label. So for me, I don't like it, okay? I like to label it. So for road D, okay, the hot end, usually I like to label it as a TH. And then for the join, okay, join, I'm going to label as TJ, okay, T join. And then the cold end, I'm going to label it as a TC. So this is what I like to do. So sometimes students, they like to label it as a T1, T2, T3. It's up to you, okay? It's up to you. But label it, okay? Label will help you to try to identify, okay? Maybe you have done some careless mistake. Then all this label, all this subscript, they will help you to identify where is your mistake. So the cross-sectional area for both road, they are the same. Okay, so you put an insulator around them. So whenever you have a joint road case, joint road questions, usually they have same cross-sectional area. So in which it means AD is equals to AE. So which is equals to A. Okay, so you can write it down as a value without subscript because they are the same. And then the road, they are in a steady condition. So again, steady condition, this term itself, it tells you dq over dt for road D is equals to dq over dt for road E. Okay, they are the same. So now let's see. Questions 1. Determine the temperature gradients along road D. Temperature gradients along road D, now you want dt over dx. So dt over dx for road D, it is equals to, now T final in my case, along road D is tj. The T along joint road, okay, the T along the joint. So minus, okay, minus what? Minus TH, the hot end, divided by XD. Okay, so you need to be extra careful with the length because now road D and road E, they have different length. Okay, so I'm going to label it as XD and XE. So it is equals to, now TJ is 80 degrees C minus the hot end, which is 100, divided by 0.2. So it is equals to negative 100 degrees C M negative 1. Okay, negative 100 degrees C per meter. So that is the temperature gradients along road D. So when it comes to these joint road questions, okay, joint road questions, you need to identify which one is your object, which road you are looking at. For instance, questions 1 is talking about road D, and the questions 2 is talking about road E. So you have two different road in the two different questions. So you have to be extra careful. Okay, now let's look at questions 2. Questions 2, the temperature T at the free end of a road E. So now it's asking for this TC, the unknown T degrees C. Okay, so we don't know the value. But what we do know, now my object, they are in steady state. Okay, so when it comes to a question that asks you to determine the values of a temperature, usually we will start from this equation. dq over dt d equals to dq over dt e. Okay, because if you're just looking at the road E, you don't have enough information to calculate TC. Why? Because you don't have the rate of heat transfer. So if you don't have the rate of heat transfer and you apply this equation, dq over dt equals to negative ka dt over dx, then it means you have two unknown in one question. Okay, so this is unknown, this is unknown. So you cannot solve it straight away by using these equations. The only choice is by using this equation, okay, this relationship. What tells you the rate of heat transfer is equal to the rate of heat transfer in road D, okay, road D and road E. So now let us expand the equation. When you expand the equation, you have to be extra careful. Why? Because you need to know which one, okay, which variables they have the same value and which one they don't have the same value. They are different. So dq over dt along road D, it is equals to negative k. Now k depends on material. Road D and road E, they have different material. So kd, okay, kd. And then A without subscript, because according to questions, both of them, they have the same cross-sectional area. And now I have dt over dx for root D. It is then equals to negative ke A and then dt over dx for root E. Okay, so before I expand the equations, I can remove the similar terms on the both sides first. So I can cancel out the negative sign, and then I can cancel out the A because they are the same. Okay, because they are the same on the both sides of the equations. So now I want to expand the equations. KD is then equals to, now dt for root D. If you look at root D is the one in blue color. So the initial position is your H. DH, this is initial. And the final position is the joint, okay, not the co-end. So you have to be extra careful. You need to know where is the initial and where is the final position. So it should be Tj minus Th divided by Xd. It is then equals to Ke, now bracket dt over dx for root E. dt over dx for root E, now let us look at the green color road. If you look at the green color road, the initial position is no longer TH. Okay, so the initial position is now your TJ. So TJ is the final position for road D, but it is acting as the initial position for road E. Okay, so it is initial position for road E, and TC is now the final position. All right. So this one you can write it as TC minus TJ divided by XE. So if you look at the equation, the part that you have to be extra careful is where should you put the temperature at the joint. okay, your TJ. So this is a very common sin mistake in the exam as well, where students they misplace the temperature. Okay, they misplace the temperature. They use TJ minus TH, TJ minus TC. So in that case, you're going to get the wrong answer. All right. So be extra careful with the temperature at the joint. So now that I have the equations, okay, I can then substitute the values into the equations. So a KD, now KD, I have K here. According to the questions, KD is equals to K, and KE is equals to 2 over 3K. So KD is K, bracket, TJ is 80 degrees C minus 100 divided by 0.2. It is then equals to 2 over 3K. And then TC. Now, TC is an unknown, so you keep it as TC minus 80 degree divided by 0.4 meters. So remember, it should be in SI unit. Okay, now if you look at the equations, both sides of the equations come with K. So you can then cancel it out.
Potong.
Potong. So macam biasa, kita main potong-potong. So rearrange the equations. TC is then equals to negative 100 degrees C M negative 1. So this is how you calculate the temperature. Okay, this is how you calculate the temperature. So now I give you 2 minutes to write it down before we proceed to questions B. Okay, before we learn how to sketch dt against the x graph. Okay, t against x graph. So 2 minutes for you to write down the solutions. And if you have any questions, you may ask. So this is a typical examples for a joint road questions. Okay, 2 minit sebelum kita tengok macam mana nak buat graph.
Madam,
Yep.
apa tu, yang negatif 20 Celsius tu salah ke jawapan dia yang kat tepi tu? Fokus untuk soalan nombor 2 tu.
Saya salah tengok jawapan, sorry.
Okay.
Saya
So the answer
tertengok.
20 lah.
Ya, the answer is negative 20. Saya tersilap pandang soalan A.
Okay.
Thank you.
Okay.
Okay, so now let's look at the questions B. Questions B asks you to sketch a graph that shows the variations of temperature with distance. So temperature with distance graph is a T against X graph. Now, when it comes to graph sketching, if you're not given any value, okay, these questions you got the value, so that's quite easy. If you're not given any value and you want to sketch a graph for a joint road, then what should you do? You should compare the values of thermal conductivity. So you look at the values of KD and you look at the values of KE and see which one is greater, okay, which one is larger. So according to the questions, KD is equals to K, KE is equals to 2 over 3K, which means KD is larger than KE. Okay, KD is larger than KE in this question. And then, now that you have KD larger than KE, then how are we going to determine which one has a greater gradients? Okay, which one is a steeper? So you try to look at the relationship between K and dt over dx, the temperature gradient. So according to the equations, K is inversely proportional to dt over dx. All right. So if your K is larger, then it means your dt over dx is smaller. So which means if KD is larger than KE, then the temperature gradient dt over dx for D, it should be smaller than dt over dx for E. Okay, so what does it mean? Now, this is the values of gradient. So which means the gradient for root D is smaller than the gradient for root E. Okay, so root E is steeper. Okay, root E lebih turun. Sebab root E adalah nilai gradient. Nilai gradient untuk E lebih besar daripada D. Based on the equation. Okay, based on the values of K given. So the values of K, other than it tell us which one is a better conductor, it also tell us which one has a steeper graph when it comes to a T against X graph. All right, so now you have a T against X. So T, I'm going to put it in terms of degree C. My X, according to question, is a meter. I'm going to put it in meter. This question is being very nice to you. Why? Because it gives you the value. So it tells you this is 0, this is 0.2, and then here is 0.6. Okay, and then you have here, let's say 80 degree, and then here is 100 degree. Right, and then this position is 20 degree. So root D, okay, root D is start from 100 degree and it drops to 80 degree. So this is the gradient. Okay, this is the gradient for root D, right? For root D. So gradient for root D. Let me really sketch it. Okay, tak cantik sat. Okay, so dotted line. So this is the gradient for root D, right? And then when it comes to root E, okay, the root E, so what you should do, okay, change the positions a bit, it's too far away, so it should be somewhere here. Okay, so when it comes to root E, so root E, the final temperature is 20 degree, so this is how you sketch your root E. Okay, so this is for your root E. So root E should be steeper than your root D. Okay, root D dan root E, bila kamu bandingkan dia, root E dia lebih turun. Okay, gambar raja saya susah nak nampak sedikit sebab saya tak lukis ikut skala. Okay, kalau nak boleh je saya edit sikit. So this is 100. Okay, so dia kurang turun. Okay, it's less steep compared to root E. So if you're not given any value, then what you should do, you just have to make sure you have the right shape. Okay, you just have to show which one is steeper in your questions. Sekiranya Anda tidak diberi nilai. So these questions you have the value. Now in exam, in case you're scared that you might have the wrong shape, then you just draw it according to the actual skill. Okay, kamu buat ikut skala yang betul. Kalaulah kamu risau kamu dapat bentuk yang salah. Okay, sebab kamu ada nilai sekarang, okay, because you have the value. Then you can draw it according to the actual skill, okay, based on the actual skill, actual value. But in case you don't have it, then this is how you solve it. Okay, this is how you determine the shape of the graph. So you need to know both method, okay, you need to know both method, especially the one in the green color box here. Sebab kadang-kala soalan dia tak akan bagi kamu nilai. Okay, dan dia akan minta Anda sketch graph. So Anda kena tunjuk, okay, yang kita check punya, other than the exist and the unique, we are going to check the shape of the graph. And the main thing that we're going to check is which one is steeper. Okay, sebab kalau kita kata sketching, sketch tak payah ikut nilai yang betul. So kami tengok apa? Kami tengok bentuk dia. Okay, so macam mana kami nak tengok bentuk dia? Kami tengok nilai K. Dari nilai K saya tahu E sepatutnya lagi turun daripada D. So kalau kamu punya lukisan D lagi curang daripada E, salah. Kalau kamu lukis E lagi curang daripada D, then betul. Okay, so sekiranya tidak diberi nilai, that is how we are going to solve it. And these questions you have the value, so it becomes very simple. You can just sketch it according to the actual value, okay, according to the actual skill. All right, so now I give you again 2 minutes to write it down. Make sure to write down the thing in this green color box because it's very important. Okay, because it's very important. It tells you the shape of the graph. It tells you which one is steeper. How should you sketch the graph? What is the relationship between the temperature gradient and also the thermal conductivity? Right? So 2 minutes from now untuk kamu sketch. Okay, untuk kamu lukis dan buat catatan. Catatan dalam kotak hijau itu sangat-sangat penting.
Madam,
Mhm.
untuk line gradient road E tu,
Aha.
memang dia takkan sentuh x-axis kan? Dia
Sebab soalan
takkan
ini dia sampai 20 degree saja. Kalau soalan ini sampai 0 degree, then Anda kena sentuh x-axis.
Oh, I see. Okay. Alright.
Okay.
Thank you.
Okay, so let's look at questions 4. Questions 4, a copper plate of thickness 1 cm is sealed to a steel plate of thickness 10 cm as shown in the figure. Okay, so now you have a steel and then you put a layer of a copper plate in front of the steel. So it is 1 cm and 10 cm here. So again, this is a joint rod type question. So start from here is your TH, your hot end, and then the joint, and here is the cold end. So the temperature of the exposed surface is the copper, it's a 30 degrees C, and 15 degrees C is the cold end. Given K copper is 385 and K steel is 50.2, determine the temperature of the interface between the copper and the steel plate. So this temperature of interface is your TJ. So you want to calculate TJ, then obviously you have only one choice of the equations, okay? Because you don't have a dq over dt. So basically you are going to apply the steady state conditions equations. So dq over dt for copper C, it is equals to dq over dt for steel. Okay, dq over dt for steel. So now expand the equations. dq over dt copper is negative kCa because they have a same surface area according to the diagram. So dt over dxc, it is then equals to negative ksa dt over dx steel. Cancel out the negative sign and then cancel out the a. Okay, so we are left with kc. So expand the equations. I have T join minus T hot over XC. It is equals to KS. Now it's T cold minus T join. Okay, divided by XS. Now that I have these equations, basically Well, I'm almost done. Okay, I just need to substitute the value into my equations. So a Kc is 385. Oops. Okay, 385, and then T at the joint is unknown. That is the things that you want to determine. Minus 30 divided by 0.01 meter. All right, make sure it's in SI unit again. And then your Ks given 50.2. And then your T code is 15 minus Tj divided by 0.1. So make sure your TJ is at the right position. Okay, TJ kamu di tempat yang betul. So rearrange the equations. Eventually, you will obtain the temperature at the interface at the joint is equals to 29.8 degrees C. Okay, so that is the answer for questions A. Then questions B. Questions B asks you the amounts of heat flowing from the copper plate to the steel plate in 1 minute. So when we talk about the rate of heat transfer, we are talking about the amounts of heat that is being transferred in 1 second. Now question is asking for the heat transfer in 1 minute. So how are we going to solve it? Well, obviously, we're going to begin with the dq over dt because we are talking about the rate of heat transfer. So dq over dt is equals to negative Ka dt over dx. Now, which one should we choose? Okay, which rod, which plate should we use in our calculations? Either one. All right. You can choose to use a copper plate. You can choose to use a steel plate. It doesn't matter. Why? Because when your object is in steady state, dq over dt copper is equals to dq over dts. So it's up to you whether you want to use the one for copper or you want to use the one for the steel. Okay, so for example, I use the one for copper. Then this would be Kc and then dt over dxc. Okay, so now I'm going to expand the equations. So dq divided by, now 1 minute is 60 seconds. So it is equals to negative, okay, negative, and then bracket. My K is 385. And then given cross-sectional area is 50 cm square. So 50 cm square is 50 times 10 to the power of negative 4 meter square. Oops, I don't have to write it here. Okay, 10 to the power of negative 4. And then dt. So dt, I have the joint is a 29.8 degrees C according to questions A. So 29.8 minus, okay, minus the hot end, which is 30 degrees C, divided by the length 0.01. So dq is equals to 2310 joule. All right, so every minute you have a 2310 joule flowing through the plate. Okay, flowing through the plate. So that is how you solve questions B. Okay, that's how you solve questions B. So if you use the rate of heat transfer for a copper, then make sure all of the information that are coming from copper. Okay, your K, your dt over dx, they are for copper. If you use dq over dt for steel, then make sure your K and dt over dx is for steel. All right, it's from steel. So that's it. Okay, that is the last questions in heat conduction. So now you can write it down, and then we're going to take a short break. Okay, we're going to take a 5 minutes break. Let us continue at 5 past 3. Okay, kita rehat 5 minit sebelum kita proceed ke subtopik yang baru, yaitu thermal expansion. Okay, so catat ini and then take a short break.
Madam,
Yes?
boleh tak Madam explain macam mana DT tu dapat 60?
Macam mana? Di apa? Mana saya ada tulis 60?
Kan DQ
Yang
over
Oh,
DQ
1
over
minute.
DT.
1 minute 60 second, right?
Yes. Okay, faham. Okay.
As a unit.
Okay. Thank you, Madam.
Okay, so now let's look at expansion. So there are 3 types of expansion in our syllabus. The first one is a linear expansion. Okay, and then we have area expansion. And then the last one is a volume expansion. So when it comes to linear expansions, now what does it mean? It just means that, okay, the length of something is increasing. So for example, if you have a road, okay, you have a road. So the length of the road is increasing. This is the length. So the length increased, maybe it extend a little bit. So this is what we call expansion, linear expansion. You're looking at something at 1D. Okay, so this part we call elongation or extension. Okay, now second thing, okay, so expand. The second things that we have here. Now, in case if you are given a circle usually is we say it's about area, right? But we can solve it by using linear expansions method. If you are if you are just looking at its diameter, okay, if you are looking at just the diameter of the area, means that you are just looking at one line, one straight line. So you see how much it expands. So in that case, we can say it's a type of a linear expansion as well. Even though the whole area of the circle increased, but if you're just looking at its diameter, then it can be treated as linear expansion. Okay, it can be treated as linear expansion. And then the last one is, okay, if you have a box, for example, is a 3D diagram. Okay, if you have a 3D diagram, and then once again, you're just looking at one line, one side. So this one, you can also call it linear expansion. Okay, so basically, if you're just looking at one line of the object, then that one is our linear expansion. So when it comes to linear expansion, okay, the equations that we have is very simple. The change in the length is equals to alpha L naught delta T. That is the equations. And I think if I'm not mistaken, this is the equations given in the exam. And if you want to calculate the final length, then you have to expand the equation. So delta length is final length minus initial length. So you expand the equations and rearrange it. Eventually, you will obtain L is equals to L naught 1 plus alpha delta T. So these are the equations that can be used to solve linear expansions questions. Okay, it depends on whether you want to find a change in the length or you want to find the final length. So that is for linear expansion. Next one is the area expansion. So area expansion, you are looking at the change in area. So for example, now that you have the circle again, but now you're not going to look at its diameter again. Okay, you look at the whole A. This is your initial A. So now this area expand. Okay, it expand, becomes larger. Well, sometimes it could become smaller, okay, if it contract. So now expand, and this is your final area. So in this case, the change in the area can be calculated by using beta and then A initial delta T. Okay, and if you want to calculate the final area, then A is just equals to A naught, 1 plus beta delta T. Now, as you can see here, the equations is very similar. Okay, the only difference is in terms of the symbol that you use. So basically for volume and then aerial and also linear expansion, they have the same equations. The only difference is the symbol, the variables that you use in the equation. Okay, the format is the same. So a volume, okay, now volume, you are not looking at the side anymore. You're looking at the whole object. Okay, so this whole thing expand. This whole boxes become larger. Okay, becomes larger. So it expand. Let's say now it becomes so much bigger. Okay, so this is expansion. So you have a V initial and then you have V final. So again, the change in V, okay, the form of the format, the form of the equation is the same. The difference is the symbol that you use. So just now we use delta A, now we use delta V. Just now we use beta, now we use gamma. Just now we use A initial, now this one is V initial. So delta T, right? And then the final volume is just V equals to uh, V naught, oops, V naught bracket 1 plus gamma delta T. So that's it. Okay, that is all in expansion. Expansion, basically, you have to identify which type of expansions you're looking at, and then from there, you determine which equations to be used to solve the questions. And the one thing that I wanted to take notes, okay, the thing that is missing in your lecture notes is the relationship between alpha and beta, and also alpha and gamma. So beta is equals to 2 alpha, and gamma is equals to 3 alpha. You need to know this relationship. Why? Because quite often questions will give you either one. Okay, then you have to change it according to the types of expansions that you're looking at. So sometimes you might have linear expansion, but questions give you gamma. Then you need to know how to determine the values of alpha. Okay, how to determine A. Alpha, yeah, A, you can call it A. All right, so that is the relationship. Now, what is the purpose of these coefficients of expansion? Alpha, we call it coefficients of linear expansion. And then beta, we call it coefficients of area expansion. Gamma, we call it coefficients of volume
Volume
expansion.
expansion.
So what is the purpose of these three types of expansion? What is the information that you can get from the values of the coefficients? Well, if you have a value, okay, you have an object with a larger coefficient, then it means it will expand faster. Okay, if your alpha is larger, then the object will expand faster. It becomes longer. Okay, and if you have a greater B beta, then it will expand faster when you compare two different objects. And that's why when it comes to volume, okay, when you place something inside a container and you heat it up, okay, so let's say now this is example. So now you have a container and then you have a liquid. Okay, you have a liquid. So this is a liquid. So you place it, you fill it up to the edge of the container, and then you heat up both objects. Okay, you heat it up. You heat both of them together. So when you heat both of them together, liquid, it will expand faster. Why? Because liquid, the gamma for liquid is larger than the gamma for the container. Okay, it's larger than the gamma for the container. Okay, therefore it expands faster. That's why overflow happen. Okay, that's why when you heat it up, okay, the liquid will spill out. Sebab dia expand lagi cepat berbanding dengan container anda. Container anda dia expand lambat berbanding dengan liquid. Okay, so kalau kamu fill up the liquid penuh, ngam-ngam penuh pada hujung, pada edge of the container, dan kamu heat it up, then overflow akan berlaku. Okay, so in that case, you can calculate overflow by using two different methods. Either you calculate the change, okay, so overflow. So V overflow can be calculated by using the change in the liquid minus the change in the volumes of the container, or you can calculate it by using the final volume, also can. Alright, see which one is easier for you to use. Okay, so kamu boleh guna V final, tolak V final liquid, tolak V final container, atau kamu guna the change in liquid, tolak the change in container. Why? Because initially you assume they have the same value. Okay, you assume V initial liquid is equals to V initial container. Kalau kamu penuh fill it in penuh-penuh ngam-ngam begini. Okay, ngam-ngam terus sini. Then dia akan sama. Initial volume dia akan sama. Then how to calculate overflow? You have two methods. Okay, you can either use a change in the volume, or you can either use the final volume to calculate the overflow. You will get the same answer if you have the same initial value. Alright, sekiranya initial tak sama, then you need to think a bit. Okay, you need to think a little bit on how to calculate the overflow volume. Okay, so this is the summary. Now I give you 1 minute to write down this summary. Okay, 1 to 2 minutes to write it down before we proceed to questions. Okay, kalau kamu faham summary ini, soalan akan jadi sangat senang. Right, 2 minutes for you to write down the summary before we proceed to questions. Okay, now let's look at questions 1. Zoom it in a little bit. All right. So now a steel ball has a diameter of 1.7 cm at 27 degrees C. So given the coefficients of the volume expansion for the steel is 3.3 times 10 to the power negative 5 degrees C negative 1, calculate the diameter of the steel ball at 77 degrees C. Okay, so if you look at these questions, you are given diameter. Okay, you are given diameter. So like I told you just now, if you're just looking at one line of the object, then it belongs to linear expansion. But then if you notice, the question gives you the coefficients of volume expansion. Volume expansion is for volume. Diameter is for linear. Then what should you do? So given gamma equals to 3.3 times 10 to the power of negative 5 degrees C negative 1, and we know gamma is equals to 3 alpha. So by combining these two pieces of information, okay, so alpha is equals to 1.1 times 10 to the power of negative 5 degrees C negative 1. Now that you have alpha, and then you know the initial diameter, your initial length, and then you have the temperature. This is the initial temperature, T initial, given T final. So can we calculate the final diameter? Yes, we can. So D final is equals to D initial bracket 1 plus alpha delta T. Okay, so D final is equals to now D initial given 1.7 cm, or you can just leave it at cm. Okay, so if D initial is cm, then D final is cm as well. So 1.7 bracket 1 plus alpha is 1.1 times 10 to the power of negative 5. Change in temperature 77 minus 27. Okay, so you close the bracket, and D final is then equals to 1.701 cm. Okay, 1.701 cm. So basically, you just repeat the same step for questions B. So D is equals to 1.7, 1 plus 1.1 times 10 to the power of negative 5. Okay, now your final temperature is a negative value, so you should keep the negative value. So negative 56 minus 27. So this is what you should do. Okay, this is what you should do. So D final is then equals to 1.698 cm. Okay, so it becomes smaller. Okay, dia mengecut. Why? Because now it becomes colder. From 27, it drops to negative 56 degrees C. So that is how you solve questions A and B. Okay, so this is your questions B. This is your questions A. So now I give you 1 minute to write it down, especially the one in the red color. Make sure you know how to calculate alpha, the coefficients of linear expansion. Right, so be careful. You're given volume expansion. You want linear expansions. Okay, you want linear expansion. So 1 minute for you to write it down. All right. Let's look at questions 2. Question 2 is a very interesting question. So now at 20 degrees C, a steel ball has a diameter of 0.9 cm. So now you have a steel ball again. Okay, so this is the ball. So diameter D is equals to 0.9 cm. And then while the diameter of a hole in an aluminum plate. So now you have an aluminum plate right here. Okay, you have aluminum plate right here. So this aluminum plate, it comes with a hole. But now this hole, the diameter is just equals to 0.899 cm. So the ball, it cannot pass through it, right? So calculate the temperature of the steel ball. When it just passed through the hole, if both ball and plate, you heated it in the same time. So sekarang kamu panaskan dia. Now you hit both of them at the same time. So at what temperature it will be able to pass through it? So 20 degrees C tak boleh. So you heat it up. So what does it mean? So it just mean that now your D final, okay, D final of the ball is equal to the D final of the plate. Okay, so ini saya panggil sebagai D initial untuk ball and then D initial untuk plate. Okay, D initial ball, D initial plate. So what am I going to do right now? I'm going to expand the equations as usual first. Okay, I'm going to expand the equation. So D final is equal to D initial. So D initial for the ball. Well, I'm going to relabel it. I don't like this. So D ball initial. Aha, now looks nicer. So D plate initial. So D ball. Wait, wrong color. D ball initial bracket 1 plus alpha delta T. It is then equals to D plate initial 1 plus alpha delta T. Now, one thing that you have to be careful, plate and ball, both of them, they are made of a different material. So alpha need to have subscript. So alpha B and alpha P. Okay, because they are made up of a different material. So if they are the same materials, then they will have the same coefficient. Okay, kalau kedua-dua dibuat oleh bahan yang sama, then dia akan ada nilai yang sama. Tapi sekarang kedua-dua dibuat oleh bahan berlainan, so dia ada nilai berlainan. That's why di dalam Anda punya equations, Anda perlu masukkan subscript. Okay, Anda perlu masukkan subscript. Okay, now let's see. So the ball is a red color. Let's see. The B initial, I have 0.9000 according to questions. Bracket. And then this is a bracket 1 plus. Okay, I'm going to put a square bracket here. So 1 plus alpha. Now alpha for the ball is a steel ball. So we use coefficients for steel. So 1.1 times 10 to the power of negative 5. Change in temperature now, T final minus T initial. T final, I don't have the value. That is the things that I want to determine right now. So I'm going to write it as T. So T minus 20 degree. And then close the bracket. It is then equals to dP final. So dP, now I'm looking at the plate. So a dP initial, sorry. So I'm looking at the plate. So plate is 0.8990 bracket 1 plus, now the alpha. Since plate is made up of aluminum, so I use alpha aluminum. So 2.2 times 10 to the power of negative 5. And then again, T minus 20 degree, because now both of them, they are being heated up from the same temperature. They will end at the same temperature. So you just have to use a T to indicate the final temperature. All right, so initial, both of them, they are 20. Final, both of them, they are T. So T is the values that we want to find. So rearrange the equations and eventually you will obtain T equals to 121 degrees C. Okay, T is equals to 121 degrees C. Now, does it make sense? If you look at these two values, okay, if you look at the alphas for steel and also the alphas for the aluminum, well, it is makes sense. Okay, it does make sense. Why? Because now the alpha for aluminum is larger than alpha for steel. So it means aluminum will expand faster than the steel ball. Therefore, when you heat it up to certain temperature, okay, the hole will become large enough for the ball to pass through. Okay, for the ball to pass by. Right. So that is how you justify it. Sometimes the question might ask you to explain why. Then you explain in terms of the values of alpha. Okay, so alpha steel is larger than alpha aluminum is larger than alpha steel. Therefore, alpha aluminum it expands faster than the steel ball. Okay, that's why when you heat it up to a certain temperature, the hole will become large enough for the ball to pass by. Right? So kalaulah soalan minta Anda explain kenapa di temperature 121 degree bola boleh melalui lubang ini. So kamu explain dari nilai alpha. Alpha aluminium lagi besar daripada alpha steel, so dia expand lagi cepat. Okay, so bila dia expand lagi cepat, mestilah dia akan menjadi cukup besar untuk bola pass by, okay, melalui dia. Okay, masuk lubang tersebut. So now I give you 2 minutes to write it down, including the justifications that I give you just now. Okay, you compare in terms of alpha. So alpha aluminum larger than alpha steel. And therefore what happened? Write it down by using your own sentence. Okay, sendiri buat catatan. Sekiranya Anda dapat satu soalan explanation, macam mana Anda nak explain? Right? So 2 minutes for you to write it down, including the explanation. Write it down in your own words. Make sure you understand it. Okay, remember, yeah, to write down the justification, because sometimes you need to explain it. For example, for the next question, you need to explain why overflows can happen. Right, now let's look at questions number 3. Oops. Questions number 3. A 50 cm cube brass container is full of glycerin at 30 degrees C. When the temperature of the container rises to 40 degrees C, how much of the glycerin spill out? And explain why there's an overflow. Perkataan why. So you need to know why. Okay, you need to know how to explain it. So I just told you, right? I just told you how to compare it, how to explain it. So now let's see how to calculate how much of the glycerin is spilled out. So you have a 50 cm cube brass container. It's full of glycerin. So it means your glycerin is also 50 cm cube. All right, and then both of them, they are at 30 degrees C. Now you heat it up to 40 degrees C. So how much is spilled out? So it's up to you whether you want to use a final V to calculate it or you want to use a delta V to calculate it. So let us try delta V. So V overflow is equals to delta V glycerin minus delta V container, okay, or the brass, okay, the brass container. So now I want to calculate delta V first, okay, delta V for glycerin is equals to gamma glycerin times V initial glycerin, okay, V glycerin initial, and then change in temperature. So it is then equals to 4.49 times 10 to the power of negative 5 times with the initial, which is 50 times 10 to the power of negative 6 meter cube. And the temperature change is a 40 degree minus 30 degrees C. Okay, so 40 is a final, 30 is initial. Now, when it comes to expansions, you can have negative delta T. Okay, it's unlike in a conduction. Conduction is definitely flowing from higher temperature towards lower temperature. But when it comes to expansions, you may cool down an object. So in that case, you could have a negative delta T. All right. So you have to be extra careful with the initial and the final value. So initial value in this question is 30 degrees C and the final value is 40 degrees C. So we use 40 minus 30. And delta V is then equals to 2.85 times 10 to the power of negative 8 meter cube. Oh, not 2.85, sorry, 2.45. Okay, 2.45 times 10 to the power of negative 7. So you just repeat the same step for a brass. Okay, so V brass. So a gamma brass, V brass, initial delta T. So it is equals to 1. Now cannot use 1.9. Why? Because if you look at the questions give you alpha. And now you're looking at volume expansion. So therefore, you need to change it into 3 alpha. Okay, so here it will become 3 alpha for brass times V brass initials delta T. Therefore, it is equals to 3 times 1.9 times 10 to the power of negative 5 V initial, V brass initial, yes, 50 times 10 to the power of negative 6. And again, temperature is 40 minus 30 degree. So the answer is 2.85 times 10 to the power of negative 8 meter cube. Okay, times 10 to the power of 8 meter cube. So from here, you can then determine the overflow. So it is equals to 2.45 times 10 to the power of negative 7 minus 2.85 times 10 to the power of negative 8. is then equals to 2.165 times 10 to the power of negative 7 meter cube. All right, so that is how you solve it. Okay, that is how you solve it. You calculate delta V, and then you calculate overflow. So how to explain it? Okay, so this is questions 1. Questions 2, now explain why. So it is
Madam,
because, yeah,
yang volume glycerin tu bukan 50 darab 10 negatif 2 lah.
kamu ini unit conversions gagal dah ini. Ini cm cube.
CM
cm
cube, okay.
cube, kamu nak tukar ke meter cube. So macam mana nak tukar?
CM cube kepada meter cube.
Hmm.
Cek.
Nah, ini careless mistake. Bukan cm ke meter, cm cube ke meter cube. So kamu kena cube kan dia. Okay, so explanations questions. So gamma for glycerin. Oops. So gamma for glycerin, if you look at the value, is larger than the gamma for brass. So you need to calculate, okay? You need to calculate the gamma for brass. So you are given alpha, you need to calculate gamma. And then you do the comparisons. So by comparisons, you know that gamma glycerin is larger than, is greater than gamma brass. Therefore, okay, therefore, glycerin will expand more than brass. Okay, and therefore it will spill out. Okay, and that's why there's an overflow of glycerin. That is because of the gamma. So gamma glycerin larger than gamma brass. So it will expand more. So that is the keywords, okay? Expand more. So when you compare the two value, you compare two coefficients, you check which one is larger. Okay, so same things can same phrase, same words can be used to explain questions 2 just now. Alright, ayat yang sama kamu boleh guna untuk explain, tak ada masalah pun. Okay, tak ada masalah pun. So unit conversions, kalau dah lupa nanti kamu pergi tengok balik chapter 1. Chapter 1 memang kita ada explain dah. Macam mana nak tukar cm square ke meter square, macam mana nak tukar cm cube ke meter cube. Alright, so 3 minutes for you to write it down before we proceed to next questions. Okay, kalau dah siap, anda actually boleh cuba questions 4. Okay, next questions. Okay, so let's look at next questions. So these questions, a glass flask whose volume is 1000 cm cube at 0 degrees C is completely filled with mercury at this temperature. When the flask and mercury are warmed to 100 degrees C, 15.5 cm cube of the mercury overflow. Aha! So this question is still about overflow, but what is the difference now is that it gives you the volumes of overflow. So now you have V overflow. Okay, V overflow is equals to 15.5 times 10 to the power of negative 6 meter cube. And then it asks you to calculate the coefficients of volume expansion of the gas or of the glass. So given the coefficients of volume expansion of mercury is 18.0 times 10 to the power of negative 5, determines the coefficient. So dia suruh kamu determine gamma. Gamma for the glass. Aha. So you are given V overflow, and then we know that V overflow at the same time is equals to delta V mercury. Oops. Okay, delta V mercury minus delta V glass. Right. So combining these two pieces of information, okay, we then know that 15.5 times 10 to the power of negative 6 is actually equals to delta V mercury, mercury minus delta V glass. Okay, so what should we do next now? We are going to expand the equations. Okay, we don't want to split into three equations like just now. We combine everything into one equation to make it easier. So 15.5 times 10 to the power of negative 6 is then equals to gamma mercury V mercury initial delta T minus gamma glass V glass initial delta T. To make it easier, you write it like this. Okay, then what are you going to do next? You just sub the value into the equations. So 15.5 times 10 to the power of negative 6 is then equals to gamma mercury given 18 times 10 to the power of negative 5. Initial volume is 1000 cm cube. Okay, so it is 1000 times 10 to the power of negative 6 times with the temperature change 100, because 100 minus 0. Okay, 100 minus 0 is equals to 100 minus, okay, minus gamma G is the one that we want to determine. Okay, because question asks us to determine the coefficients of volume expansion of the glass. So gamma G is a thing that we don't have right now. And then the initial volume is still the same, 1000 times 10 to the power of negative 6. Temperature change is also 100 degree. Right, so rearrange the equations. Gamma G is then equals to 2.5 times 10 to the power of negative 5 K negative 1. So this question is actually very simple. Okay, it's same as the previous questions, only that you have to start from overflow. Okay, you do it in a reverse way. So just now you calculate delta V and then you calculate overflow. Now from overflow, you go back to the informations. Okay, you go back to the coefficients of expansion in the questions. So I give you 2 minutes to write it down. And then questions 5. Questions 5, I'm not going to discuss it. Why? Because questions 5 is exactly the same as questions 3. So questions 5, I will leave it as a homework for you. You try it by yourself. Right? So 2 minutes to write it down, and then we will proceed to question 6. The last questions for today's section. So 2 minit Anda catat, and then soalan 5 kita akan skip. Kita akan sambung ke soalan 6. Okay, let's look at the last questions. So questions 4 is just a very simple question. It's just a reverse of the overflow questions that you have tried in the questions 3. Questions 5, I will leave it to you. Okay, it's exactly same as questions number 3. If you don't know how to do it, you may refer to questions number 3. Now let's look at questions number 6. Questions number 6, a hollow aluminum cylinder has an internal capacity of 2000 cm cube. It's completely filled with a turpentine, something like that, okay, at 20 degrees C. So they are then slowly warmed together to 80 degrees C. So how much of it is overflow? Okay, how much of the liquid is overflow? So initially, again, you have this cylinder, okay, and then you fill it with the turpentine, and then now this is what happened initially. Okay, so this is 2000 cm cube. All right, 2000 cm cube initial volume, your V initial, and then initial temperature T initial is 20 degrees C. All right. So how much overflow? So overflow again, same method. Delta V, V overflow. V overflow equals to delta V. Delta V of what? Delta V T minus delta V. Delta V of a cylinder, aluminum cylinder. So I'm going to call it AL. Okay, AL. And then it is equals to VT initial and then a gamma T delta T minus gamma aluminium V aluminium initials and then delta T. So it is then equals to 9 times 10 to the power of negative 4. Initial is a 2000 times 10 to the power of negative 6. Change in temperature 80 to 80 minus 20 minus, okay, minus, okay, now be careful again, you're given alpha, you see, that's why I tell you just now, you have to be extra careful with the coefficient. Sometimes, okay, sometimes you're given a case in volume expansions, you're given a volume expansion examples, but questions give you coefficients of linear expansion. So since this is an alpha, therefore it should be 3 times 24 times 10 to the power of negative 6. That is your gamma aluminium. Okay, times with a 2000 times 10 to the power of negative 6. And again, the temperature is 80 minus 20 degree. So the overflow is equals to 99.36 times 10 to the power of negative 6 meter cube. So that is the answer for questions A, overflow. Now, questions B. Okay, questions B is the tricky part. Why? So it asks you, what is the volumes of the turpentine remaining in the cylinder at 80 degrees C? So you want the final volume, but you're not looking at the final volume of liquid. Why? Because if you look at the coefficients of a volume expansion, turpentine, it expands more compared to aluminum cylinder. So the additional liquid is overflow. Okay, it flows out from the container already. Therefore, the remaining liquid should be equals to the volume of the cylinder. Okay, should be equals to the final volume of the cylinder. So V aluminium, that is what we want. Okay, V aluminium is equals to V initial. Oops, not V initial, sorry. Yes, 1 plus gamma delta T, gamma aluminium. So it is equals to 2000 times 10 to the power of negative 6. And then 1 plus aluminium, okay, against 3 times 24 times 10 to the power of negative 6. And then times with the 80 minus 20 degree. Okay, so this is what happens in the equations. So V aluminium, V final aluminium is then equals to 2008.64 okay, times 10 to the power of negative 6 meter cube. All right, or you can write it as 2008.64 cm cube. So this is the remaining, okay, the remaining liquid in the cylinder. So you want the final volume of the cylinder, not the final volume of the liquid. Why? Because if you take final volume of the liquid, that is definitely larger than 2008, okay, 2008 cm cube. Why? Because some of the liquid, okay, this amount of liquid is overflow, right? So sebanyak ini sudah overflow. So kalau kamu kira final volume untuk liquid, dia akan lebih besar daripada silinder. Okay, so soalan ini saya kata tricky sebab apa? Sebab dia tanya kamu volume of the liquid remaining in the cylinder. So actually it's asking for the final volume of the cylinder. Okay, it's asking for the final volume of the cylinder. So that's it. Okay, that is the answer for questions number 6. So dia soalan tricky dekat soalan B sahaja. Alright. So if you have any questions, you may ask. If no, that's all for today class.